Okay, the last one that we're doing. Question 8 on June 2008, core 1. Might not have been that paper, whatever. There we go. Find dy by dx if y equals this bit here. Now we're told this curve has 2 stationary points. That's quite a nice start. We know there will be 2 values where... what happens at stationary points? dy by dx equals 0. So instantly from the question we're reading that, and we're reading that means where dy by dx equals 0. That's important. So part 1, just find dy by dx. That's it. Well, that means we just need to differentiate this. Go through it term at a time. X cubed goes to 3x squared. Forget the k for now. X squared goes to 2x, but we're multiplying by k, so it's minus 2kx plus x, so plus 1. Remember, it's only x that you're differentiating, so if we have another letter in here, it's just behaving like a number. It's only ever x that we differentiate. If there happens to be a letter, my group did a homework recently where there was a letter A in there as well. Don't get distracted by it, just pretend it's a number. It's only x for differentiating. That's 2 marks, we've done it. Part 2. Given that there is a stationary point when x is 1, find the value of k. So this is telling us now that dy by dx equals 0 when x equals 1. That's what they're saying, given that the stationary point when x is 1. So if that's true, then we're going to sub 1 into that equation, and it will be equal to 0. So 3 times 1 squared minus 2k times 1 plus 1 is equal to 0. We've got, what was it, 3 minus 2k plus 1 is 0. That looks like that says 4 minus 2k is 0. Are we happy that k equals 2 out of that? There we are. We've just picked up another 3 marks. Determine whether this stationary point is a minimum or a maximum point. As soon as we read those words, actually there are words that trigger things off here, aren't there? As soon as we read those words, minimum or maximum, that tells us that we want to differentiate again. We want to find dy by dx squared. So what have we got now? We already now know, as we come to part 3, that dy by dx is 3x squared, k is 2, so that's minus 4x plus 1, that's right, isn't it? We had 3x squared minus 2kx plus 1. So that's what dy by dx is. So the second derivative, if we just differentiate that expression one more time, 3x squared goes to 6x, minus 4x is going to go to minus 4, and the 1 is going to go to 0, so we're there. We've got 6x minus 4. We are interested in what happens when x, at that stationary point, when x equals 1. So if x equals 1, dy by dx squared is 6 times 1 minus 4, which is 2. Well, that's great. It's 2. We need to think, what does that mean actually in practice? And we know that if the second derivative is positive, which way around is it? If the second derivative is positive, it's a minimum. If that had been negative, it would have been a maximum. That is greater than 0, therefore we have a minimum. Quite formulated. Can I spell that right? There we go. Nice few marks, another 2 marks there. Find the x-coordinate of the other stationary point. Well, hang on, what have we got here? We know that dy by dx is 3x squared minus 4x plus 1. At the stationary point, dy by dx is 0. So that means at the stationary points, 3x squared minus 4x plus 1 equals 0. The other stationary point just means what's the other x value that satisfies this. So we could try and factorise this. Let's make life as easy for us as we possibly can. We already know that one of the stationary points is when x is 1. So one of the brackets, if we were going to factorise it, would be x minus 1. That would give us the result x equals 1. If that's the case, then the other bracket, well, it has to be a 3x at the start. There's no other option. And it has to be another minus 1 at the end, so that minus 1 times minus 1 gives us plus 1. And so we've got x equals 1. We already knew that. We've got x equals a third. That's what we wanted. That's the other stationary point. And we're done.